Let's talk about molar concentration. But first, let's define two concepts, solvent and solute. The solvent is the component of the solution present in larger amount, for example, water. And the solute is the substance dissolved in the solvent, for example, salt. And together, they make a solution. For example, we can have salt in water. Then let's define the molar concentration. So the molar concentration of a solute in a solution is the amount of solute molecules, or formula units in moles, present in a given volume of the solution in liters. This concept can be summarized in the following equation. So the molar concentration, or molarity, is equal to the amount of solute in moles, for example, salt. You find the number of moles, and is divided by the volume of the solution in liters. And it can also be written as an equation where C is equal to molarity, and this is equal to N, number of moles of solute, divided by V, volume in liters. Finally, we can prepare a solution doing the following steps. First, we weigh the amount of solute that we need according to the number of moles, and we pour it in a flask. Then we put a little bit of solvent, like water, to dissolve this salt. And then we put the rest of the amount of water up to the desired volume and make sure that the meniscus is at the mark of the desired volume. So we do this procedure of putting the solute before the solvent because there are cases where the solute includes some molecules of water. And to account for that, an easy way is to put the water at the very end. That way, we keep track of the final volume of the solution, which is what we care about in molarity. Let's go over one example to show you how to use this equation by calculating the molarity of a solute. Example 1 says, suppose you dissolve 10 grams of cane sugar in enough water to make 200 milliliters of solution, which you might do with less precision if you were making a glass of lemonade. Okay, so from this sentence we see that cane sugar is the solute and water is the solvent. Then it continues, cane sugar is sucrose with this molecular formula and this molar mass. What is the molarity of the resulting solution? Okay, so we're given 10 grams of sucrose or cane sugar, and we need to convert this to number of moles. And we're given also that the volume of the solution is 200 milliliters, and we have to convert these to liters to use this formula. Okay, let's do the first one first. So to convert the 10 grams of sucrose into number of moles, we use the given molar mass. So 10 grams divided by 342 grams of sucrose for every 1 mole of sucrose. The units of grams go away and we're left with units of moles. Notice that we start with 3 significant figures, so we must end with 3 significant figures. So the final answer gives us 0.0292 moles of sucrose. Then the volume of the solution, 200 milliliters, must be converted to liters. To do that, we use the following conversion factor. We have 1,000 milliliters for every 1 liter. So the units of milliliters go away, and 200 has a dot at the very end, so it has 3 significant figures. So we must end with 3 significant figures. Dividing 200 by 1,000, we have 0.200 liters with 3 significant figures. Finally, we can use the equation of concentration or molarity, and the number of moles of solute is 0.0292 moles of sucrose divided by 0.200 liters of solution. So we have on the top and the bottom three significant figures, and in a division we must use the minimum number of significant figures. So it's a final answer with three significant figures. So we get 0.146 molar, which is moles per liter, with three significant figures as desired. We can also find the mass of a solute given a concentration. Let's go over this example. A chemist studying the properties of photographic emulsions needed to prepare 500 milliliters of 0.179 molar silver nitrate, AQ. AQ means that the solution is water, so it means aqueous. What mass of silver nitrate must be placed into 500 milliliters volumetric flask, dissolved and diluted to the mark with water? Okay, so we're trying to find the mass of silver nitrate that is needed to prepare 500 milliliters of this concentration of silver nitrate. Okay, so we have that the volume is 500 milliliters, and this is the volume of the solution, and the concentration of the solution is 0.179 molar silver nitrate aqueous. Okay, so if we want to use this formula, we know that we need to convert this volume into liters. So let's do that first. So we can convert this with the following conversion. For every 1000 milliliters, we have 1 liter. So milliliters goes away with milliliters, and we are left with 0.500 liters. So this is the volume that we need. Remember that there is three significant figures, and three significant figures in the answer as well. Okay, so to find the mass of silver nitrate, first we need to find the number of moles of the solute of silver nitrate, and then convert this to the mass of silver nitrate by using the conversion factor of the molar mass of silver nitrate. Okay, so we can rearrange this formula by multiplying both sides by volume. So volume goes away with volume, and we have that volume times concentration equals the number of moles of solute. And after we find the number of moles of solute, we convert it to mass in grams. Okay, so let's first find the number of moles of silver nitrate that we need. The volume is 0.500 liters, and we multiply times 0.179 molar, which is moles of silver nitrate for 1 liter. So liter goes away with liters, and we're left with number of moles. So multiplying this 0.500 times 0.179, we get 0.0895 moles of silver nitrate. And remember that the final answer must have three significant figures, because both of these factors have three significant figures. Then to convert this number of moles to the mass of silver nitrate, we need the molar mass. So the molar mass of silver nitrate is, we have 1 mole of silver in the formula, 1 mole of nitrogen, and 3 moles of oxygen. So we multiply these by their respective atomic masses. So it's 107.87 for silver, 14.01 for nitrogen, and 16 for oxygen. So all the units of moles go away and we're left with units of grams. So we have the same number for the case of silver, same number for the case of nitrogen, and 16 times 3 gives us 48 grams for oxygen. Adding this up, we get 169.88 grams, and this is per unit mole of silver nitrate. Okay, so with this calculated molar mass, we can get the grams of silver nitrate. So we have this number of moles of silver nitrate, and we multiply times 169.88 grams of silver nitrate for every mole of silver nitrate. Moles goes away, and multiplying these two numbers gives us a final answer of 15.2 grams of silver nitrate. And remember, this answer must have 3 significant figures because the minimum number of significant figures is here, 3. Finally, we can also calculate the amount of volume of solution for a given solute amount. Let's go over this example. A medical researcher investigating the properties of intravenous solutions prepared a solution containing 0.278 molar of glucose. What volume of solution should the researcher use to provide 4.50 millimoles of glucose? Okay, so in this problem, we're given the concentration. So concentration is 0.278 molar of glucose. And we're also given the number of moles of glucose. So N is 4.50 millimoles. And we know that if we want to use this equation, we need to convert these to moles. So to convert millimoles to moles, we just say that for 1,000 millimoles, we have 1 mole. So after doing this, dividing 4.5 by 1,000, we get 0.00450 moles of glucose. Remember that this must have 3 significant figures because the initial number has 3 significant figures. Okay, so we're trying to find the volume of solution, so this V in the formula. So we can rearrange this formula by multiplying volume and dividing by concentration on both sides. So concentration goes away with concentration and volume goes away with volume on the other side, and we're left with volume equals number of moles divided by concentration. So this is the formula that we will use. So we have the volume is equal to number of moles, 0.00450 moles of glucose, divided by the concentration 0.278 molar, which is moles of glucose per liter of solution. So moles goes away with moles, and we're left with units of liters. So dividing these two numbers, which each has 3 significant figures, we have final answer of 0.0162 liters, and these must have 3 significant figures as well. If we want to find this in milliliters, we just convert it to milliliters by the following factor. For every 1 liter, we have 1,000 milliliters. Liters goes away with liters, and we have 16.2 milliliters. And that's our final answer.